All right, today we are just doing a little review for our upcoming quiz, Quiz 4. So first I'm saying write each of the following in 3 formats. So we want words, we want component form, and as a translation rule. So I'm doing it by the columns. So if I look at my first one, if we want to say we want to translate left 7 up 12 in component form, that's our pointy brackets. Left 7 would be -7. Up 12 would be a +12. Okay, as a translation rule, I would start with x, comma, y. There's my ordered pair. And we're saying for each point, we want each x value -7 and each y value +12. Okay, in my next one here, this column, here I have my component form given as -9, 4. So in words, that's saying, well, go left 9, and that +4 means, well, go up 4. Okay, how do we write that as a translation rule? We start with the xy, so we're saying do this for all points. Okay, and then we're saying, well, for each x value, we want to take away 9, and for each y value, we add 4. Okay, and then my last column here, we're given a translation rule that reads as x + 5 and y + 8. So it's telling us go right 5 and go up 8. Okay, in component form, right, those pointy brackets, right 5 is +5, up 8 is +8. Okay, next in problem 2, we're going to actually do the translation. Let me slide up just a little bit. So we're saying take this triangle that is graphed. Let me zoom in a little bit tighter so you can see that more clearly. So translate triangle PIN using this vector. So -4, 5. So it's telling us how to move it. It's saying, okay, we want to go 4 left, and then we want 5 up. Okay, so let's start with P. So 4 left, 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5. Okay, and my new P, I mark as P prime. It looks like an apostrophe, but it reads as prime. Okay, for I, same thing. 4 left, 1, 2, 3, 4, up 5, 1, 2, 3, 4, and 5. So here is I prime. Okay, with N, 4 left, 1, 2, 3, 4, up 5, 1, 2, 3, 4, and 5. So here's my N prime. And then I'm going to take my ruler, take my straight edge, and connect those dots. Okay, and then just as a reminder, I'm going to draw in one of the vectors, right, that is moving point I to I prime. So I just want to show you again what it's actually doing. So here is that vector pathway that is sliding I into I prime's position, right, because it's moving 4 left and 5 up. And each of these points would be doing the same thing. N sliding into N prime's position, P to P prime as well. And if I drew in all of those vector pathways, I would see that they are running parallel to each other. All right, if I rewrite this as a translation rule, well, my translation rule will always start off as XY, arrow to the right. Okay, 4 to the left means each x value, we're going to subtract 4. And 5 up, we take each y value and we add 5. All right, so here is my translation rule. Okay, let me slide over and look at problem 3. So in problem 3, we're going to translate as well, but we're going to follow the translation rule, and then we're going to write it in component form. So this one is saying, in the rule, x minus 2. So it's saying, okay, we want 2 left. And then y minus 5 is saying, well, we also want 5 down. All right, so let's say I start with n, 2 left, and 5 down. 1, 2, 3, 4, and 5. So it puts me right here where that a is. I'm going to write n prime. Okay, a, 2 left, 5 down. So here's my a prime. And for p, 2 left, and 5 down. So here's my new p prime. And then I'm just going to connect my dots. And it looks like so. So just a reminder that a translation is a type of rigid transformation. So we know that our figures remain congruent. They remain perfectly identical, right? Because each point is moving that same distance in the same direction along parallel pathways. So if I drew in the vectors here too, I would be able to see those parallel pathways more clearly. All right, component form. So here are my pointy brackets. 2 left would be negative 2. 5 down would be negative 5. All right, lastly, we zoom out a little bit because we're a little too zoomed in. We have a composition problem. So whenever we're looking at a composition, we're really just looking at back-to-back transformations. And the only transformation we have learned about so far, right, is a translation. So we're going to do back-to-back translations. So if I look at my first one, the instructions are saying 2 right and 5 down. So 2 right and 5 down. So I start there. So 2 right and 5 down. 1, 2, 3, 4, 5. So here's my new G. Here is my G prime. Okay, for A, 2 right, 5 down. 1, 2, 3, 4, and 5. So right here would be my A prime. And then P, 2 right, 5 down, right here. So here is my P prime. So connect the dots. We've done our first translation. So that single prime notation tells us it is the first translation in the composition. So again, a composition is just saying we're doing back-to-back transformations. And again, since all we've learned about right now is the translation, that is what we're starting with. Okay, so now the second one, the second translation, the rule is saying go 3 right and 1 up. So 3 right and 1 up. So it's building off of this translation right here. So building off what you see as purple with the prime notation. So we're taking the G prime and we're going to move 3 right and 1 up. So right here will be my G double prime because it's my second stage of my composition. Okay, looking at A single prime, 3 right and 1 up puts me right here. Here's my A double prime. Again, it's my second stage in the composition. Okay, I'm looking at P single prime, so 3 right and 1 up, so P double prime. Okay, connect all these points that I've plotted in green. So it should be here, here, and here. So again, a good tell that you've done this correctly is, well, are all of your figures still congruent? They should absolutely still be congruent, all three of those triangles on this grid right here. So with any rigid transformation, our figures remain congruent, the pre-image and the image. And since we had two stages here, that's why we used a single prime notation to get us here, and then a double prime here. So it's saying this is the first stage of the composition, this is the second stage of it. Okay, lastly, it's saying, well, now write the composition as a single translation in both formats. So here I can see, okay, overall, we went 5 right. Right, we're thinking what got us from here, the initial pre-image, to our final image here in green. So here we see, okay, we went 2 right, 3 right, 5 right total, 5 down, 1 up. We are still 4 down from the original figure. So in component form, in those pointy brackets, we would say positive 5, that's 5 to the right. 4 down is negative 4. Okay, as a translation rule, we would say, okay, well, x, y, arrow to the right. All the x values, we're adding 5. All the y values, we're taking away 4. All right, so a good review of all the translations that we've done up to this point. All right, let's do a little flip. Go to the back side. All right, so here in this problem, we are told that F and G are running parallel. So I'm going to use my colors here to emphasize the parallels. So F and G, bright red. I'm going to show the arrow for my parallel notation. And I'm trying to figure out how do I get to these measures right here. So I want to first look at the numbers that are marked and think about what it is that I can fill in based on that information. So the first thing that I see before I even mark a transversal is I see right here that these 3 angles are on a straight pathway. That's a straight angle. So I know that together, all 3 of these must add up to 180. So right now, the 70 and the 54, that's 124 degrees. So if I think, well, what's 180 minus 124? That will leave me with 56 degrees. Okay, and then that might help me get started by then filling in all of these angle measures right around here. So if I connect their vertical angles, I can see that right here would be 54. Right, vertical angles are congruent. We have proven it. 56 here means 56 over here. 70 means 70 here. So I know angle 2 has a measure of 56 right now. Okay, now I'll focus on one of the 2 transversals. So I'm going to go like this and mark this one in blue. Just helps me see things a little bit more clearly. So now I can see where this 70-degree angle is, for example. It could slide into its corresponding position right here. So corresponding angles, we know that they are congruent. So right here, we're at 70 degrees. And then its vertical angle here would be 70 also. Okay, and then the supplement of 70 is 110. And I know that these form a linear pair. So I gotta have 110 here and then 110 here. So I know that angle 3 has a measure of 110 as well. All right, and then the measure of 1. So I'm looking right here for the measure of 1. So maybe I will emphasize the other transversal in green. Okay, I like using the colors because it just helps me block out the noise and focus on certain parts of my diagram. So this 56 right here, for example, right, I see that it's sandwiched in between the green and the red. So that 56 can slide into its corresponding position right here. So here, 56 degrees. I can connect its vertical angle here, 56 degrees also. I'm seeing that my triangle adds up to 180 as it has to be a triangle. And then to get to angle 1, I just need the supplement of 56 because together they form a linear pair. So 180 minus 56 is 124. So both of these angles would be 124. So angle 1 has a measure of 124. All right, the next one here, problem 6. Determine if lines are parallel given the following information. So we're given this diagram that is clearly not drawn to scale, but what we're saying is if we can get to a certain angle relationship, if we can show that certain angles are congruent or supplementary, it has to be the correct relationship. That leads us to the lines being parallel. And since we're starting with an angle relationship and building towards the parallels, we know that these are going to be all converses. So let me write that here. They're going to be converses. Right? The starting point is the angle relationship, and we're building towards the lines being parallel. All right, so first up, here I'm saying, well, let's focus on 5 and 6. So 5 and 6 are supplementary. Let me just circle them. And I'm going to block out the noise because those angles are not connected to line C in any way. So I'm going to block them out temporarily. So I want to look at angle 5 and 6. I want to think what kind of angle pair are those angles? And I should recognize that they are same side exterior angles or consecutive exterior angles. And since they're supplementary, that is the correct relationship. That leads us to these being parallel pathways, A and B. So I can reach my conclusion that A has to run parallel to B because of those same side exterior angles that are supplementary. So my reason would be the converse of the same side or consecutive, that would be fine, exterior angles theorem. And we've proven this a few times now. So we know that if we start with same side exterior angles, that does lead us to our lines being parallel. All right, next we're looking at 3 and 4. So let me erase what I've already marked. So 3 and 4, right here. So if I'm blocking out my noise here, well, 3 and 4, they're not connected to these lines here or here, right? Because those are vertical angles. Well, vertical angles do not lead us towards parallels in any way. We have to be looking for corresponding angles, alternate interior or exterior, or same side interior or exterior. So knowing that those are congruent and they're vertical, again, it does not lead me to the lines being parallel, so none. All right, how about 1 and 2? So if I look at 1 and 2 right here, okay, let me block out the noise, right? Line A has nothing to do with it, so let me just go ahead and block it out of view. So here I can see that if they are parallel, it would be C and R with B as the transversal. So what kind of angles are 1 and 2? They're corresponding angles, and that is the right relationship. So I can say that C and R do run parallel. And my reason would be the converse of the corresponding angles postulate. All right, so in problem 6, I just want to stress that if we're trying to build towards having parallel lines, right, then we know that that's citing a converse. We're starting with the angle relationship and we're building towards the parallels. All right, number 7, write an equation of a line in slope-intercept form that is parallel to the line, or not parallel, perpendicular to the line provided and passing through the given point. So if I'm looking for perpendicular and this is my given slope from my original line. My new slope is going to be -3/2. We know that our slopes are opposite reciprocals. So perpendicular slopes are opposite reciprocals. So our new slope is going to be -3/2, -3/2. Okay, the way that we've been showing it to you guys how to get into slope-intercept form is to start with point slope and then convert it into slope-intercept. So I'm going to go ahead and plug into point slope form. So y minus 6 equals -3/2 of x minus -12. When I subtract a negative, it goes to a positive. I distribute the -3/2. So y minus 6 equals -3/2 of x minus 18. Now I'm guessing that some of you can't see that as quickly as I can, so let me just multiply off to the side to confirm it. So -3/2 times 12/1. So when I'm multiplying fractions, I can always simplify top down or on diagonals, and I can see that this 12 and this 2 can simplify to a 6 and a 1. So that's where I'm getting that -18 from. Okay, last thing I need to do is add the 6 to the other side. And I get y equals -3/2 of x minus 12. So that's my equation. Y equals -3/2 of x, take away 12, minus 12. All right, next up, we're getting back on the coordinate plane, so I'm going to zoom in again, just get a little bit tighter. All right, find the shortest distance from a point to a line. So we should know that our shortest distance will always be the perpendicular pathway. So I'm going to start by graphing my line. So I see that my y-intercept is at 0, 5. And my slope is -1/2. So down 1, right 2, down 1, right 2. And I'm just going to give myself a whole bunch of points along that pathway. All right, so here is my line. And then my point is 1, -3. So 1, -3. I'm going to plot it right here in purple. All right, so the shortest distance from a point to a line is always that perpendicular pathway. So I'm looking for that segment and what its length is. So here, I know that my new slope then, my perpendicular slope, has to be the opposite reciprocal. So it has to be a +2. So with a pencil, I'm just going to start at this point, go up to right 1, up 2 and right 1, up to right 1, and so forth. So here would be the line that would slice through the other line, passing through the given point that it's running perpendicular with. But what I really want, is I want the measure right here from the point to the line. And again, we know that they're running perpendicular. So I need to figure out either what are these 2 points, use the distance formula, that's fine, or I can visualize this right triangle like you guys have seen me do a whole bunch in class. So if I draw that out, here's my triangle. Okay, my leg here is 3 units. That's the horizontal difference between them. And then the vertical distance between them is 6 units. So Pythagorean Theorem is a squared plus b squared equals c squared. So we've shown how we solve for c. C is equal to the square root of a squared plus b squared. So I'm just looking at what is the square root of 3 squared plus 6 squared. So 9 plus 36, square root of 45. Well, that's 5 times 9. That 9 gives us a pair of 3's. So our distance would be 3 root 5. All right, one more problem. So over here, I'm giving you a diagram. So we see that we have parallels and a transversal, and I'm giving you the measure of angle 1, 2, and 3, all as expressions. So what I really have to do is I need to look for certain relationships in my diagram to get some equations started. So first one that I see is right here. So 1 and 2, right there, those are same side interior angles. So they are supplementary. So I'm going to go ahead and I'm going to take the measure of 1, add it to 2, and make sure it's equal to 180. So 14x plus 8y plus 7x plus 7y equals 180. Okay, and if I clean that up, combine the like terms, so combine the x's, I have 21 x's, the y's, I have 15 y's, all equal to 180. And I'm kind of at a dead end right here because I have two variables, but I've rewritten it in standard form. So now I'm going to look at my diagram and look for another relationship, and I can see the first one that stands out to me is right here. 2 and 3, those form a linear pair. They are also supplementary. So I'm going to build off that. So I know then that 7x plus 7y plus 12x minus 2x equals 180. And if I clean that up, 7x plus 12x, we have 19x. 7y minus 2y is plus 5y, all equal to 180. Okay, just to point out, just in case you saw a different relationship, another one you could have built off of was 1 and 3. So 1 and 3 are alternate interior angles. I could have also gone through those. Alternate interior angles are congruent. So I could have built a second equation off of that relationship too. All right, so now that we have these two equations, they both have two variables, we want to solve it as a system. So I'm going to join those two equations together. So 21x plus 15y equals 180. 19x plus 5y equals 180. All right, so if I'm using a system and I want to solve it, I need to figure out what my method's going to be. Do I want to use substitution? Do I want to use elimination? I would use elimination here because I don't want to create a fraction unless I have to. And I can see that with those y's, it's pretty easy to make opposites. I just have to multiply everything on the bottom by a -3. All right, so now I have 21x plus 15y equal to 180, and then -57x minus 15y equal to -540. So now I'm ready to add down, and I get -36x. The y's clear to 0, right? They're opposites, equal to -360. Divide by -36, and we get that x is 10. So now if I want to go after y, I can pick one of the two equations to plug back into. So let's say I go right here. 19x plus 5y equals 180, and I plug in that 10 for x. 19 times 10, we get 190. And then plus 5y equals 180. And then from here, I'm going to take away the 190. So 5y equals negative 10. And when I divide by 5, I get that y equals negative 2. Okay, and if I go back to my expressions here, and I want to plug in, so 14 times 10, right, we're at 140. And then here we're going to have minus 16. That's going to give us 124 for this angle. So 124 degrees. Okay, 7 times 10 is 70. And then minus 14 will get me 56 for this angle. So 56 degrees. Okay, that makes sense because these add back to 180. And then angle 3, this one has to have a measure of 124 also, but let's plug back in. So here I have 120. Negative 2 times negative 2 is plus 4. So we have 124 right here. It's always good to plug back in if you have time, just to verify that you've solved correctly. All right, that's all I have for today. Enjoy the rest of your day.